Hello everyone, thank you for watching this Connect with Remedy webinar. My name is Doug Reif and I'm the Principal Technical Support Analyst with BMC Software. And today's webinar is on plugin server basics. Today we'll answer the question, what are plugins? We'll look at the different types of plugins and the different types of plugin servers. And then we'll look at the different types of communications available with plugins. And then we'll follow the webinar with some references so you can go back and do some more research later. So what are plugins? Plugins extend the ARSystem server functionality to external data. That's data that's not contained in the ARSystem database. They allow integration between the BMC Remedy ARSystem and external programs or environments. All plugins are registered with the plugin server, which runs them as needed and coordinates all the interaction. This slide is a bit technical, but it should help you understand what plugins actually do. Plugin API functions provide the main routine, threading control, and communication with the ARSystem server. The plugin application provides the logic for one or more callback routines defined by the API that perform operations against the external program or environment. When a plugin is invoked, the ARSystem server makes a call to the plugin server requesting a specific plugin to perform a specific operation with a set of parameters. The plugin server then passes the parameters to the appropriate callback routine in the external application and waits for a response. When the response is received, it's returned to the ARSystem server and processing continues. I picked a handful of plugin API functions from the documentation just so we can take a look at kind of what the plugin does. One thing it can do is run the area verify login callback, which is used for authentication to validate a user login. Another one is the RDBC get entry, which can grab a record from some external data source. The RDBC get list entry with fields function will perform a query on some external data source. Then you have RDBC set entry, which allows you to actually save an entry to an external data source. And ARFilter API call is the function that filter APIs run inside a filter to perform an operation with an external plugin. Plugins are not just valuable for customers to build their own integrations, but they're also valuable to BMC when writing our own integrations or performing functionality that just can't be done with workflow. So BMC extends functionality in our out-of-the-box applications through the use of plugins. This allows tight integrations and purpose-built code. So there's something that's very specific we want to do that can't easily be done with workflow. We can do it through a plugin. It also can offload the work to an external process. So if we had some functionality that might require a lot of CPU or memory to use, we can do that, but we can use that memory and CPU inside a plugin rather than inside of AR server. So let's look at the types of plugins that we have. First, we have the ARFilter or ARF plugin. ARFilter plugins enable you to create tight, efficient integrations between your systems and the ARSystem server. They're triggered by set fields actions in filters or escalations. Because this middleware is loaded as a plugin, when BMC Remedy ARSystem server is started, instead of as a standalone executable at each event, it consumes fewer resources and less processor time than a set field $process action would. So in the past, you might have a executable you created or some kind of code that you created and you called it from Remedy workflow, and how you would call it is a filter with either a set fields $process or just a run process action, and that would create a shell each time you called it, and that shell would consume a certain amount of memory and CPU. So with the plugin, you have one instantiation of that code, and then it just gets called by the AR server each time you need it. So this takes up less CPU and memory, especially it takes up less CPU and memory inside of AR server because those resources, as I mentioned, are used in the plugin server. So some of the key aspects of the ARFilter plugin is that it offloads processing to an external process, so it doesn't spawn a new shell each time that you need to call that routine. And it runs outside the ARSystem server space. So not only does this allocate resources to a plugin server rather than AR server, it also helps keep AR server more stable because when a plugin misbehaves, it's not going to affect the ARSystem server itself. Error filter plugins help solve workflow problems by coding in a familiar language or using a desired protocol. So for example, you might find that Perl is a familiar language to you. Well, you could actually write your code in Perl and have a filter API call that code. In fact, there is a example Perl plugin available in the communities, which I've linked to at the reference section of this documentation. And also, let's say that you want to work with a specific protocol, like with SOAP, you want to use web services. Well, as you've seen in some of our prior versions, prior to 9.0, we had filter API plugins that would make calls to web services. So these are just examples of some of the types of filter API plugins that you might use. If you want to look at what BMC uses out of the box, we use filter APIs in quite a few places, and just a few examples are the CAI or Command Automation Interface plugin is used by ITSM, SRM, and custom applications. It's used to create, update, and receive data from other back-office applications. Its key usefulness is that it provides dynamic data mapping mechanism because you can't use workflow to push values to dynamic fields. So we use this in several places. Another common plugin is the ITSM util. This is used by RKM to set the knowledge article. It's also used by approval to create or delete an approval filter when a user defines a custom approval chain. And another example is the Twitter alert. This provides a way to send an alert notification or a tweet to a valid Twitter account. So now let's look at RDBC or ARSystem database connectivity plugins. These are used to provide access to data that's stored outside the ARSystem database. The plugin presents data as if it were located in tables owned by BMC Remedy ARSystem, just like regular forms would be. The ARSystem administrator can create a vendor form that references the table and columns or other formats of data of the external data source as fields on the form. So you can have an external data source that was, say, a file, and maybe each row of the file was presented as if it was a separate field on a form. Views and workflow can then be built on top of those vendor forms just as if they were regular forms. The source of data is transparent to the user. All they see is data on a form. They don't actually know where that data came from or that there was a plugin that presented that data. The link between the form and the backend source is dynamic. So what you're seeing on the form is live data from the backend data source. If you modify data on the form, that likewise modifies the data on the backend source because it is a dynamic link. Here's a few common uses for RDBC plugins. One is to represent configuration data as if it was form data. So Remedy provides a form called configuration ARDBC form, and this form reads configuration data from the ARconfig file, and it presents it as if it was form data. And so you can open that form and you can look at your config file, and it's a dynamic link to that file, so you got to be careful, don't change anything on that form. We also provide the ARDBC LDAP form, which is often used to onboard user information and is also used to maintain user information because it's a dynamic link right to your Active Directory or other LDAP data source. One of the RKM plugins reads file information and presents it as a form. It looks at files and it can get certain information from those files and present it as form data. So those are all pretty interesting uses for this type of plugin. Some of the out-of-box examples that we provide, some of them I just listed, but one is the admin console. Did you know the administration console is a vendor form? So most of the information that is on the vendor form comes from a plugin that performs GSI, get server info, API calls, and presents the data that was returned as if it was form data. So it's pretty interesting use. I just mentioned the configuration ARDBC vendor form, which reads the ARconfig file. We also have the ARSystem multi-form search, which is used by RKM and used for your global search. That's actually a vendor form, and the plugin takes your search and it converts it into a Lucene engine type of search, performs a search, and then takes the results and presents it back to you as form data. So let's look at area. ARSystem external authentication plugins. These provide a way to validate users by connecting the ARSystem to a data source outside the ARSystem database. This can be done using the Area LDAP plugin or by creating your own custom plugin for authentication services such as Kerberos. One of the features of Area plugins is that the user can exist entirely in the user form except for the password, or completely outside the user form, or any variation of that. So for example, you might already be storing the usernames and passwords and already have a password management scheme going on in Active Directories. So maybe your users are already changing their passwords every 90 days, and you have the the password complexity already set up there, and you don't want to have to worry about also storing the password in Remedy and then worrying about password complexity and all that. So you can have the user exist in Remedy except for the password, and you use Area simply to validate the password. You also could have users that have some combination. You have some information in the user form and some of it comes from LDAP, all the way to the point where the user doesn't exist in Remedy at all. He only exists in LDAP, and from LDAP we can get the user's login name, we can validate the password, we can get group membership, license information, and any other information that's required for that user. I also mentioned chaining on the previous slide. Chaining can occur between the user form, OS or operating system authentication, and one or more area plugins. So chaining can be quite complex. I'm not going to talk about all the different aspects of chaining, but we have multiple types of chaining. So you've probably seen the authentication chaining mode. That's an option that you have in the external authentication settings for Remedy. And so that allows you to chain between a user that's in the user form, a user that exists on the operating system, such as the Windows operating system, or a user that exists in LDAP. And so chaining means we can try the user, we can check to see if the user exists in the user form. If he does, great, we'll log him in. If he doesn't, then we'll try the operating system or LDAP. And if he doesn't exist on any of them, he fails. But eventually we will try the area plugins to see if he exists. Well, once we make a call to the area plugin, then that plugin server can also chain, because you might have multiple area plugins installed. For example, you might have some SSO plugin that you've built yourself. Maybe it does some functionality for SSO. You might already have the area LDAP plugin being used. And it's also possible that for some users you're using Remedy's SSO, the RSSO product. And so you could potentially have all three of those loaded inside one of your plugin servers. And what happens when AR server gets to the point where it makes that plugin call to that plugin server, the plugin server itself will try each one of those in order that they appear. So it might first try area LDAP. And if the user fails there, then it might try your custom SSO plugin. If it fails there, it might try the RSSO plugin. So there's multiple types of chaining that can occur, and they make area plugins fairly complex, but they make them very powerful as well. BMC provides several out-of-the-box area plugins. First, as we mentioned, we provide the area LDAP plugin that allows connections to any LDAP hosts, including Active Directories. We also provide the Remedy Single Sign-On, or RSSO plugin, that uses token-based authentication into multiple BMC products with one sign-on. And this replaced another plugin that we offered, which is the Atrium SSO, or ASSO. This is being replaced by RSSO now. We also provide a sample area plugin. So when you install the ARSystem, the Java plugin server comes with it, and the Java plugin server comes with several examples, and there is an example area plugin there that you can check into. Plugin APIs are published so that customers and vendors can create their own integrations with plugins. We also provide some examples. So wherever you have ARSystem installed, if you look in the ARServer API Java plugins directory, you'll notice there's a sample RDBC, sample area, and sample filter API plugin available so that you can start writing your own plugin using a skeleton to begin with. There's one other type of plugin that I thought I'd mention, and that's a hybrid. This is not a specific type of plugin. It's just that some plugins that come with our out-of-the-box applications ship as a particular type of plugin, but that has some extra functionality. For example, the CAI plugin is a filter API plugin. And so there are functions that are called from a filter using the filter API command, and they're called the CAI plugin. But CAI does more than that. It also acts as a standalone process that will, on an interval, process activities that are in the CAI events form. Another example is approval. Approval does a few things. One of the things that it does is it acts as a vendor form, and it is an ARDBC plugin. So it provides the data that will be populated on the AP preview vendor form. But approval plugin also performs ongoing approval requests, and it does that without somebody accessing the vendor form. Approval also performs admin operations based on approval administration activities. So we call this a hybrid because it's technically a vendor form, but it does much more than just respond to the API requests off of that vendor form. So let's look at the type of plugin servers. There's really just two types of plugin servers. The first is the C plugin server. This is the original plugin server that's been around since the 4.x version of Remedy ARSystem. In a typical environment, there's only one C plugin server, and out of the box, we ship with just one. But you can configure multiple C plugin servers. It's not too difficult, but if you are using multiple C plugins still, you can segregate those and put plugins on individual C plugin servers. The C plugin server uses the plugin-port parameter in your configuration to listen on. C plugins are multi-threaded, and they're multi-threaded based on these settings here. To make the area threads multi-threaded, in other words, having more than one thread to process area calls, you would add the plugin-area-threads parameter. And likewise, for ARDBC and filter API plugins, you can set this parameter in your configuration to provide more than one thread for that type of operation. Now, C plugins are not as stable as Java plugins. That's one thing we've seen since we've introduced the Java plugins, is that they're a little bit more stable. In the C plugin server, a single plugin can bring down the entire plugin server. And that's one reason, if you are using C plugins, you might want to consider creating multiple plugin servers and then segregating the plugins across those. The second type of plugin server is a Java plugin server, and this is now the primary plugin server that we use. The bulk of the plugins that are used and delivered with our out-of-the-box products are run inside the first Java plugin server. It's easy to set up multiple Java plugin servers, and each individual Java plugin server will have its own Java virtual machine, so it's easier to segregate your work across multiple plugin servers. And because it's Java, it's generally easier for customers to write their own plugins than it was for customers to write a C plugin. Also, I mentioned area chaining, but there's one more aspect to chaining I didn't mention, is that a Java plugin server can actually chain back to a C plugin server. So let's say in the rare condition that you had a area plugin that was written in C that you still had to support, but primarily you're using Java plugins, you still could have your area plugins in Java, and then if none of those succeeded to authenticate the user, it could make a call back into the C plugin server. So that's an interesting attribute of the Java plugin server. Java plugins and Java plugin servers are multi-threaded per plugin server. So you set up the num core threads to tell the Java plugin server how many total threads it has, and then those threads are shared across all the different plugins that are running inside that plugin server. Now let's talk about plugin communications. AR server communicates with plugin servers over RPC. Now this is the same way that any AR server client communicates with AR server. We use RPC. Now the plugin servers listen on RPC socket 390695. If you have multiple Java plugin servers and a C plugin server, they all listen on RPC socket 390695. The server plugin alias parameter in the config file or in the central config defines the host name and the TCP port for every Java plugin. So you might end up having 4 or 5 Java plugin servers, and your plugins will be running on individual plugin servers. And for AR server to know which Java plugin server to connect to, it uses the server plugin alias. C plugins use the server connect name to connect to the C plugin server, and it uses the plugin port parameter. So C plugins don't normally have a server plugin alias assigned to them. Plugins can call back into ARServer. So you might have a plugin like the administration console. The administration console, in order to populate the information on the screen, it has to make some API calls back into ARServer. So the plugins can be configured for specific host, port, and RPC socket. If you look at the Java configuration, which we'll do in a later session, you'll see where you can set up the different host name ports and RPC sockets for that to occur. But it's important to know now that plugins can make a call back into ARServer, and again, that uses RPC connections just like any other AR client. So here's a sort of a visual on how the communications take place. So the purple lines here are the RPC traffic and the orange is HTML. So you see a browser client has a request. It uses HTML to communicate with the mid-tier. The mid-tier uses RPC to connect to ARServer. You also might have another client out there, it might be using Dev Studio, and it's using RPC to connect to ARServer. Now ARServer, depending on what the request is, may make a call directly to a database, or it may make a call to a plugin server. And the call that it makes to the plugin server, and potentially a call that the plugin server is going to make back into ARServer, is happening over RPC. Let's look at another, maybe a more complex communication. So you have a client, and that client might be a mid-tier client, it might be Dev Studio or just any other client. So he makes a request, and the request goes to the ARSystem server. The ARSystem server now might take that request and make a request to the database. It also might make a request to one or more plugin servers. Those plugin servers then can connect to each of their individual external data sources. So it can get fairly complex on how the communication happens, and sometimes these are synchronous activities. Well, within a single transaction from the client, you might have one piece of that transaction goes to the database. One piece of it goes to one plugin server, and potentially another piece of that same transaction, maybe because it's a create entry call that has a lot of filters that are firing, and those filters require some access to the database. They require calling one Java plugin server and possibly another Java plugin server. So you can have a fairly complex set of activities like this. Let's look at some complex communications. These are just examples of things that I've seen that appear to be very complex. One is authentication in the middle of an API call. So here's the example. A user logs in, he performs some work, and then he maybe stops working on Remedy for a while, and his license times out. Then he comes back and he performs a query. So the query is actually a GLEWF API call. So that API call begins, but ARServer recognizes that his license is already timed out, so it has to perform an authentication. And because this user uses ARIA to log in, ARServer will now, in the middle of the GLEWF call, it'll make a plugin call to re-authenticate that user. Once he's re-authenticated, then the rest of the GLEWF occurs, and then it ends, and then the user gets his data back. Here's an example of a filter API call. This isn't necessarily complex. It might look kind of complex, but this is how a filter API is generally called. So here's a filter action that does a set fields to a filter API. And you can see you provide the plugin name, and then a call is going to be made to that plugin, and it's going to return some data, and that data is mapped back to individual fields. So that's how a filter API works. Next example is this one is fairly complex, where you can have a form query that causes both a database and a vendor form query. So not only does it connect directly to the database, sort of like that image I showed you a few slides ago, but it also connects to a plugin that's doing an RDBC vendor form call. So an example out of the box is the RKM VF file system manageable join. This is a join form that joins both a regular form and a vendor form. So in a single query, you have to actually access both a database and a non-Remedy data source, which in this case happened to be a file system vendor form. So it's accessing files on the hard drive, and data from the database, pulling them together and representing them as data on a join form. So that one is fairly complex. Something you may not have realized is you can create join forms of a vendor form and a regular form. It's not often that the need arises for that, but here's a specific case where it was actually required. So that's it. As a summary, we looked at what types of plugins and plugin servers are available. We looked at how BMC makes use of plugins. And we talked about how AR Server communicates with plugins and vice versa. And we looked at some interesting behaviors of plugins. So I hope this was useful for you. This was part one of what's hopefully a multi-part series, and we hope that you're able to join us again. And I have provided some references that I made mention of during this webinar. And you can go back and do some of your own research on this. So I appreciate you all coming. Thanks again for attending the Connect with Remedy webinar series.